Welcome to exponential growth versus decay. So we know that exponential growth is when you are increasing, and we know that exponential decay is when you are decreasing. We talked previously how you know that you're growing if your base, the b value, is greater than 1, and that you're decreasing if the base is less than 1. So now that you know whether you're increasing or decreasing, the question becomes, how much are you increasing by, or how much are you decreasing by? So the way that we know we're increasing is if we have our base now become a 1 plus r, right? Something that is greater than 1. You know you are decaying if your base is in the form 1 minus r. That gives you something less than 1. For example, if you have a base of 1.2 to the x, because your base is 1.2, we can now express this as 1 plus 0.2 to the x, which tells me that my rate is 0.2, so that I'm increasing by 20%. If I have 0.8 to the x, then I can rewrite this as 1 minus, think about if you're starting at 1, how much are you going down by to get to 0.8? That would be 1 minus 0.2 to the x, so that your rate is 0.2. So in this case, you are decreasing by 20%. Now we know that our previous variables were that a was the initial value, b was your base. We're actually going to call that your growth or decay factor. So on the top left, my growth factor is 1.2. On the right, my growth factor is 0.8. And x, your exponent, is time. Now we're going to say that P in this second formula down below is your principal value. It's the fancy word in financing of how much you are starting with. So if they say your principal value is $16,000 in a bank, it means you invested $16,000 to begin with. R is your growth or decay rate as a decimal. So you need to change that into a percentage. So again, top left, growth factor is 1.2. Your growth rate is 0.2 because you are increasing by 20%. On the right, your decay factor is 0.8. Your decay rate is 0.2 because you are decaying at 20%. And t is going to be your time in years. That means if they give you 6 months, they're going to make t equal to a half, because 6 months is a half of a year. The only thing not listed on here is what a is equal to, this guy. This is going to be your future amount. So if your principal was $16,000 with a rate of 20% for 5 years, A is how much you're going to have at the end of 5 years. Now let's actually try a few examples of breaking it down. For part A, they want you to find the initial value, which is out up front. For part B, they want you to find the growth factor. That is everything in your base, the 1.4. For part C, to find the growth rate, you need to think of this because we're increasing since the base is greater than 1. We have 1 plus r is your growth factor of 1.4. That means if you solve this equation, your rate is equal to 0.4 because you are increasing by 40%. You don't have to do the whole equation, but it does help if you can't figure it out in your head. And then the last one you want to explain, whether it's exponential growth or decay, we're going to say growth because your growth factor is greater than 1. Okay, and more specifically, you're growing at 40%. Not that that was a question, but just writing it down there. For the next one, your initial value found out front is 125. Your growth factor, the entire base, is 0.9. Because we are less than 1, we know we're decaying, and we're going to have 1 minus r equals 0.9. If you solve this equation, you get negative r is equal to negative 0.1, which means that r is equal to positive 0.1. Or just think of it as you started at 1, you're going to 0.9, so you decayed by 0.1 if you don't want to do the formula. And this is exponential decay because the growth factor, or rather in this case you can say the decay factor since we're going down, is less than 1. And more specifically, we are decaying at 10%. So a few things to keep in mind are that your growth or decay factor is the entire base, the 1.4 and the 0.9. If they're asking for the rate, it's specifically how much are you increasing above 1 or decreasing below 1, the 0.4 and the 0.1. And that's all for this video.